Welcome to your review lesson for ionising radiation and electromagnetic waves. Okay, so the first thing you need to do is answer the review questions, the do now questions, into your notebook. Press pause on the video and then you can come back and check your answers. Okay, so first things first, let's look at our three subatomic particles. So we have proton, neutron, electron. Okay, subatomic because they make up the atom. Okay, atomic is basically making up the atom. Okay, an isotope is an atom of an element. So it has the same number of protons and a different number of neutrons. Okay, what is an alpha particle? Okay, so it's a helium nucleus. So that's 2 protons plus 2 neutrons. Okay, that is emitted from the nucleus of an unstable atom, and its mass, because it's 2 protons and 2 neutrons, equals 4. Okay, a beta particle then for the next question. So a beta particle is a fast moving electron. Okay, again emitted from the nucleus of an unstable atom. Its charge equals -1. Okay, so let's define half-life. Okay, so half-life is the time taken for activity mass or number of parent number of parent atoms to reduce to 50% of the initial value. Okay, so what happens to the atomic number of an atom as it emits an alpha particle? So an alpha particle we know has a 2 for its atomic number and a 4 for its mass number. Okay, so when an atom emits an alpha particle, its atomic number will decrease by 2. Okay, and because the atomic number changes, that means we're going to get a new atom, new element formed. Okay, right, so on to activity for today. So this is our review sheet. Okay, you're going to be filling this in. Okay, I'm going to go to each separate section. I'm going to fill in those parts. Okay, and then you can press pause to help you fill in your review sheet. You may wish to fill in this review sheet on your own using the internet to help you. That is completely up to you. Okay, so we'll start up in this top left hand corner. What does the mass number mean? Okay, so that's the number of protons and neutrons in an atom. Okay, the atomic number is the number of protons. Okay, what does isotope mean? Okay, so basically same number of protons and a different number of neutrons. Okay, so when does radioactive emission occur? Okay, so that's when an unstable atom or decays. To become more stable. Okay, another way of saying that is when there's an imbalance between the protons and neutrons, okay? Okay, what needs to be unbalanced? Okay, it's about the number of protons and neutrons. Okay, so if you need to write any of that down, press pause and you can get that written down. Okay, it'll also be available at the end of the video. Okay, complete these equations for alpha decay and beta decay. So really straightforward, you should be able to do these yourself. I have got my periodic table to help me. Okay, so alpha decay, I know that I'm going to have alpha and a 2 and a 4 there. Okay, for beta, I'm going to have a beta, a -1 and a 0. I need a plus sign for each of those. Okay, and I'm going to look at the alpha decay first. Okay, so 90 minus 2. Okay, I know it's 90 minus 2 because I've 92 minus 2, sorry. I've got 92 here. I need something that goes here added to 2 to give me 92, okay? So the first thing I know that I'm going to put is 90, because I know 90 plus 2 equals 92. Okay, then I've got 2, 3, 4. Okay, take away 4, and that's going to give me 230, okay? So I look at my periodic table to find something with 90 protons, okay, and I know that that is thorium, okay? Right, so down at the bottom, beta decay. All right, so what happens on this one is the atomic number is going to go up by 1 because it's something minus 1 equals 83. So I know I'm going to have 84. Okay, the mass number stays the same. Okay, but in reality, it's the atomic number that is the most important because that tells us what element we have. Okay, and that tells me I've got PO, which is polonium. Okay, so press pause if you need to write any of that down. And we're going to go over here. All right, so talking about background and nuclear waste, that was one of our lessons. I think it was your second lesson. So name the 2 types of background radiation. Okay, we get artificial and then natural. Okay, give examples of each. So artificial. So the artificial background is sources of background that are caused by human activity. Okay, so we have nuclear power, that's power stations. Okay, nuclear testing. Okay, and medicine. Okay, so things that happen in hospitals where they do tests or killing cancer cells. Okay, natural. So we get cosmic rays that come from stars in space. Okay, we get food and drink. Rocks and soil. And plants. Okay. So, nuclear waste now. Materials left over from testing in nuclear energy, okay? So there's loads of problems associated with this, okay? Namely, it's the storing of them, okay? It's expensive. And difficult to store them safely, okay? Okay, we need to avoid that they're not going to leak, they're not going to be able to be stolen. We got to store them for a very long time as well, okay? Okay, so the half-life of depleted uranium is thousands and thousands of years, okay? So if you need anything from that slide, you can press pause there. Okay, right, on to our table for alpha, beta and gamma. Okay, I'm going to zoom in on this and I'll zoom out so that you can see all of the answers, okay? So what is it for alpha? It's a helium nucleus, 2 protons, plus 2 neutrons. Okay, what's its charge? Well, it's got 2 protons, so its charge is plus 2. Its mass is 4 because it's 4 little parts. Okay, it's very slow, well, relatively slow. Okay, and it's relatively slow compared to gamma rays. Okay, so its penetrating power blocked by skin, paper, or 10 centimeters of air. Okay, so on to beta. What is beta? Well, it's a fast moving electron. Okay, its charge, because it's an electron, is -1. Okay, its mass is 0. It's fast. It's not the fastest one, but it is very fast. Okay, and this is blocked by aluminium foil or about 100 centimeters, so 1 meter of air. Okay, on to gamma. Okay, so gamma is a high energy frequency electromagnetic wave. Okay, its mass is 0 because it's a wave, its charge is 0. Okay, it travels at the speed of light, so it's the fastest thing that we can have. Okay, and it's blocked by several centimeters of lead or several meters of concrete. Okay, so there's your answers for that part. Okay, again, press pause if you need to write any of that down. Okay, we're going to move on to the bottom right hand corner, okay, where we've got our atom. Okay, so we need to label the atom. Okay, so first up we got minuses, pluses, and then no charge. Okay, so we should be able to work what those out. This is a carbon atom, we know that because it's got 6 protons. We know it's got 6 protons, it's got 6 electrons. Okay, and then we need to know that this is the nucleus. Okay, so okay, let's move up to the top now. So we're talking about half-life. Okay, so what is half-life? So half-life is the time taken for activity, number of parent atoms, number of parent atoms or mass of a substance to reduce to half or 50% of its initial value. Okay. Right, so it says sketch a graph of the decay of 32 grams of polonium it has a half-life of 20 seconds. Okay, so first thing, let's use a ruler for those actually, shall we? That would be better. Okay, so you should be able to draw a straight line on your notebook, okay? Where it becomes difficult is that we're going to draw a curve in a second, okay? As we're sketching, we don't need to measure. Okay, so we're going to start off with 20. Let's put 10 here, 15, 5, okay? Alright, so start on 0. It's obviously time in seconds, okay? So we need to go 20, 40, 60, 80, 100, okay? Alright, so I'm just going to draw a nice little curve. So I need to be there-ish at 10 seconds and there-ish, okay? So I'm just marking out, okay? And we draw a nice curve like that, okay? I'm going to rub out the end of my curve because it will never reach 0. There we go. Alright, so I've sketched my curve for Half-Life to show the half-life, okay? So every 20 seconds the value of the mass on this side is going to reduce to half, okay? So a radioactive substance has a half-life of 30 minutes. What fraction of the atoms will decay after 1 hour? Okay, so first up I'm going to write down my number of half-lives, okay? So I'll go 0, 1, 2, 3 half-lives, okay? So that's time equals 0, and then it's going to go 30, and it goes 60, and that's an hour, so I can stop there. So I start off with 1 over 1, it goes to 1 over 2, and then 1 over 4. Oh, 1 over 4, okay? So I'll have a quarter of the atoms left. Okay, there's my answer. Alright, same again, the half-life of a radioactive isotope is 27 years. How long will it take for the mass to fall from 2 to 0.5 grams? Okay, so again I'll go 0, 1, 2, 3 half-lives, okay? So I'm going to put in the mass now. So the mass starts off as 2, then it's going to drop to 1, then it's going to drop to 0.5, and then it's going to drop to 0.25. You don't need that, but I'm just showing you how you would do it. Okay, so then let's look at the time, okay? So 0, 27, 2 lots of 27 is 54. Okay, and then after that it would be 81. Okay, so here's my answer, 54 years. Okay, again, press pause if you need to write any of that down. We're going to move on to the final part now. Alright, name the regions of the electromagnetic spectrum and give one use for each region. Complete the labels for wavelength, frequency and energy. Okay, so we've already got the labels here. Shortest wavelength is this end, longest wavelength this end, okay? We've got frequency there, should be a Y for frequency. Okay, and you can see I've got spelling errors because I've used lowercase letters. Right, so first region is radio waves. Okay, that's used for communications. It's all one word, but it won't quite fit. Okay, microwaves used for cooking. Okay, the next one we have is infrared. Okay, used for heating or cooking indeed. Okay, we've got visible light. Okay, we use that for seeing. Cameras. Okay, ultraviolet, suntans. And checking notes for forgeries, okay? Yeah, you might see in shops where they hold your banknotes underneath a blue light and they will glow in certain ways, okay? Next one, we've got X-rays. Okay, and that's medical images. If you've ever damaged yourself in a fall or something, you may well have had an X-ray. Okay, we've got gamma rays next. Okay, and they're used to kill cancer cells. Okay, right, so we already know that gamma rays have really high frequency, okay? So we know that we can put highest here, and because they've got high frequency, they've got high energy as well. Okay, and that means at the other end we've got lowest energy and lowest frequency. Okay, now I believe that is all of your sheet completed. Okay, so I'll leave that there for a second. You can pause it and get the answer that you need. Okay, and we will also zoom out, and there you go. You should be able to zoom in using your browser on the different parts that you need there. Okay, and then finally some answers there. Okay, right, thank you very much for watching. Good luck with your review sheet. Make sure you submit your assignment at the end of the lesson, and you will be having a test the lesson after this one. Okay, thank you very much.